Parallelogram is a quadrilateral where the two opposite sides are parallel. That would mean those two would be parallel. Opposite sides meaning don't have a endpoint in common, or those sides being parallel. Okay, there's properties that come directly from that. If you read these pieces, okay, one of the quickest ones to get is that the consecutive angles are supplementary. Here's the reason. If I trace these out, we've got two parallel lines and a transversal. This angles 1 and angles 2 on this parallelogram, those are consecutive interior angles. We had previously learned that consecutive interior angles are supplementary. In terms of a parallelogram, those two angles, which would mean the consecutive angles on a parallelogram, would also be supplementary. You can have a similar argument if comparing angles 2 and 3. Those would also be supplementary. All right, now in terms of one of the other ones, opposite, we'll do the second one. Opposite angles in a parallelogram are congruent. Well, here's the explanation for that. Transversal, two parallel lines. Angle 1 is congruent to this angle on the outside, correct? They're alternate interior angles, so they're congruent. If we hop to these two being the parallel lines and that being the transversal, then we can say that the angle I had marked right on the left is corresponding to angle 3. Okay, by the transitive property, angles 1 and 3 are congruent, which in terms of parallelograms would be the opposite angles. True? True. Okay. Now, another little proof. So we have those properties being true. Now, take a look at this. So we have these two being congruent, these two being congruent. Now, in terms of the sides, you actually have to draw in a diagonal into the picture. You can get by angle, side, you can get that the triangle on the left and the triangle on the right are congruent, which means that their corresponding sides are congruent, which means that these sides would be congruent, and those are the opposite sides of a parallelogram, being the same measure. And then for the fourth one, ready, drum roll. Thanks. We can talk about these two triangles being congruent, okay? We can also throw in another bisector, another diagonal. We can then talk about this triangle and that triangle being congruent, which tells us that this piece and that piece are congruent. These pieces are congruent, which turn that around. That means those diagonals bisect each other because they split each other in half. All right, those are the 4 theorems. You'll need to become accustomed to those and be able to use them. You won't really need to prove them. All right? You just need to know them and apply them. As a disclaimer, when we go to the quiz, which will be on Friday, here's good news. I'm going to let you have an open notes quiz. Okay? You can use your notes on it, this would be a really, really good thing for you to use, right? Because it gives us the particular properties of parallelograms. I'll tell you a little bit more about the quiz tomorrow after I write it tomorrow morning, after I finalize it. Okay. All right, let's look down below. Let's do these problems. These are great problems. I love doing math problems, especially math problems about parallelograms. If you read the description, the directions, if each quadrilateral is a parallelogram, I'm telling you it's a parallelogram. Okay, those properties up above only hold true for parallelograms. They do not hold true for every quadrilateral. They only hold true for parallelograms. So in terms of this picture, how would we find x? Anyone? Anyone? Number 1? Yeah. Divide 78 by 2. Why would we do that? Okay. There's a triangle here. It's a great observation. You're saying that y and x are congruent, right? To be able to do 180, 78, divide by 2 stuff. We actually can't get there yet. Okay, we can't get there because that's not an isosceles triangle. Not necessarily. It could be. It might not be, though. Yep. Okay, so you would like to find, we can find z first, if that's the way you see it. Absolutely. So the suggestion was z is going to be a linear pair with 78. Linear pairs are supplementary. Supplementary angles add up to 180. So if we do 180 minus 78, we get 102 for z. That's one of them. Okay, so there's that. So where were you going with that? Okay, are z and x alternate interior angles? Technically, they're alternate interior angles, but they're not alternate interior on parallel lines. So they're not congruent. Okay? Yeah. Is it x 29? So a suggestion is that 78. Yes, that's 78. I like a quicker way to get there is that x is actually 29. Why is x 29? You have to understand the logic. This and this are parallel since it's a parallelogram. That is a transversal. That means these two are alternate interior angles, so x is also 29. Does that make sense? So x, messing up the picture, x is going to be 29. You have to know the reasoning for that. You just can't say 29. Does that make sense? You have to understand that process. So this guy's 29. And then if we go back to the fact that we said first that there's a triangle on the top, right? We know two angles of that triangle. To find the third, we do. It's going to be 73. We're going to do, to get that, we're going to do 180 minus 29 minus 78. It's going to be 73. Why are we doing 180? Because that's a triangle, and the interior angles of a triangle add up to 180. Boom. Goes the dynamite. Okay, next question. Anybody want to find one of them? Anybody? Thoughts? Yeah. Is x 31? It's a parallelogram, so we have two parallel lines and transversal, so these pieces are congruent. Absolutely. X is 31. Anybody else want to do something? Yeah. So y is 44. Again, they're alternate interior angles for the same reason. Anybody else want to pick up z? Anybody want to take care of z? There's a quick way on z, and then there's a not so quick way. That's the quick way. The opposite angles on a parallelogram. This is a parallelogram. Opposite angles are congruent. What's the long way? What's the hard way? Yeah, she's looking at that being a triangle. All three of those angles are going to add up to 180. Absolutely. True fact. Okay? 180 minus 44 minus 31 equals 105. Any way you want to do it, that's fine. You just got to be able to do it. All right, numeral 3. Number 3. Anybody want to take a gander at it? Yep. Is x 73? Reason being opposite angles of a parallelogram congruent. Anybody else? Anybody else? Is y 73? Why? alternate interior angles. Yep. What's Z then? 27? 107? 107? How do we know it's 107? Those two are sup. There was sup. Oh, I'm a comedian. Straight up comedian. Oh, you could say y is 73, corresponding angles to the absolutely. Super. Do numero 5. There's no room on 4, so. Number 4. Or number 5. What's a good strategy to go after this guy? What's a good strategy? So we're going to draw a parallelogram. What do we need to do? Keep talking. What do we need to do? Yep. Label these guys. What else do we need to do? Where? Where's RQ in our picture? You know what I'm saying? Yeah, that is messed up. What do we got this part. What else do we need? Diagonals. Diagonals. What else do we need? What's this spot? Q, right? They intersect at Q. Yep. Do we have RT and SV in there? Or VS? Yep. So if RQ is 5x plus 1, QT, besides the fact that it's Mr. Suitor, QT is 3x plus 15. Okay. Our goal is to find out what QT is. That's the problem. Where do we go from here? Yeah. Would we do 3x plus 15 equals 5x plus 1? Would we? (3x plus 15 plus 5x plus 1 equals 180, you said? Would we? Which one would we do? We use this one. Why can we use the first one and not the second one? The first one comes from the different parts of a diagonal. Up above, we said diagonals bisect each other, which means it splits it into two congruent pieces. This statement up here mixes side lengths with an angle measurement, and that's bad. When we solve this guy, 2x equals 14, and we get x is 7. Is that QT? Nope. QT is 3x plus 15, so QT is 3 times 7 plus 15, 30 what? 6. QT is 36. Super. Hey, is number 6 a parallelogram? No. Why? 10 and 11 are different measurements, and we're supposed to have opposite sides congruent. How about 7? Is that a parallelogram? No, why not? These are supposed to be congruent, right? True fact? True fact. Go to the back, please. Mando. Number 5 was what? Measure of angle Z? 60. Number 6 was 120. Nothing fancy, just consecutive angles, right? Opposite angles. Y is 7. WX, 7. By the way, that's a rhombus over there. It's not just a parallelogram. It's also a rhombus, but we'll get into that later. All right, go for the last set. Okay. So I'll do the side measurements first. TQ being 42. SA, I'm going to do that in a different color. It's kind of hard to see since they overlap. SA being 14. TA would then be half of 42, right? Because the diagonals bisect each other. If QT, the whole diagonal, is 42, half of that is 21. SR is twice the size of half of the diagonal, so it'd be 28. SQ, 22, right? Opposite sides congruent. AQ, 21. ST, 30. And AR, 14. Okay, now back to the two angles. Way easier to do all the sides first, I think. Way easier. Okay, QST would be 65 plus 45, wouldn't it? 110. Yep. And then STR would be 180 minus that, minus 110. 70. Okay. All right, you guys do have homework.